This is Geometry A, Unit 6, Congruent Triangles, Lesson 2, Triangle Congruence by Side, 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 and Side, Angle, Side. All right, so let me review just a little bit here. If I make this statement, if I say triangle ABC is congruent to triangle DEF, here's what that means. Okay, the definition of congruent triangles. It means the measure of angle A, or angle A, is congruent to angle D. It means that angle B is congruent to angle E. It means that angle C is congruent to angle F. It means that side AB, segment AB, is congruent to segment DE. It means that segment BC is congruent to segment EF. It means that segment AC is congruent to segment DF. Okay? In diagram form, that is said this way: if these two triangles are congruent, then so are their corresponding parts, DEF. Okay, AB is congruent to DE, BC is congruent to EF, AC is congruent to DF, angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F. Okay, all of that. Now that's a lot of stuff to prove, but the question then comes to mind: is there a shorter way to prove two triangles are congruent, or do I simply have to prove that all 6 parts are congruent? And the answer is yes, there is a shorter way. There are several shorter ways. We're going to be reviewing them or learning them in this unit. They are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Okay, we're going to look at 2 of them today: side, 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 angle, side. Here's what the side, side, side postulate says. If you have 2 triangles, ABCD, ABC, and DEF, and you happen to know that the sides are congruent, AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF, then you know the triangles are congruent. And that's called the side, side, side triangle congruence postulate. It's a postulate because we take it without proof. We will be demonstrating it or verifying it in our portfolio this unit. But it is never actually proven, but it is taken as a postulate. So if you have 3 sides, we don't need to know any angles. If you have 3 sides that are congruent, that is enough to prove the triangles are congruent. Okay? Correspondingly, the side, angle, side postulate says if you have 2 triangles, G, H, and I, yes, I'm being very creative with the letters, J, K, and L, that if you have 2 sides congruent, and you have another pair of sides congruent, and the included angle between them are congruent, then the triangles are congruent by the side, angle, side postulate, triangle congruence postulate. Okay? Now I don't have enough time to do a proof using each, but it is important to note here that the angle must be included between the sides. They must be in that order. So side congruent to a side, side congruent to a side, side congruent to a side. Okay, order doesn't matter really much there except that you match corresponding parts. But here, this side is congruent to this side is congruent to this side. The angle that is included between the 2 congruent sides must be the ones that are congruent. Okay, and if that's the case, then the triangles are congruent. Let us do a proof. Okay, there are 2 big ideas. Someone's come to join me, and I'm going to have to put him down. Come on, Michael. All right. Let's do a proof. And to do this proof, oh, he's insistent. All right. Okay, so to do this proof, I need to remind you of a couple of rules. All right, a couple of rules here. All right, here we go. It's gotten me all distracted. Okay, here we go. There we go. All right, and here are the rules that I need you to remember. One is the reflexive property. Reflexive property. It's something that you learned before, but you haven't really used it much. Reflexive property says anything is congruent to itself. So A is congruent to A. Anything is congruent to itself. And it's used when you have shared parts. So let's say I've got a drawing like this. This part is shared. So if I had this here, I would say in my proof that AB is congruent to AB by the reflexive property. Okay, so look for shared parts. Parts that are in common between two triangles. Shared parts. I call it the Siamese twin rule. You know what Siamese twins are children that are born conjoined, right? They share a part of them. Okay, reflexive property. Then there is the vertical angle theorem. Vertical angle theorem. Vertical angle theorem. And here's what this says. If we have this situation where two triangles have a vertex that forms vertical angles, that is, angles whose rays form opposite rays, right? Then they are congruent, and we would say if this is A, B, C, D, E, we would say angle AED is congruent to angle CEB by the vertical angle theorem. Don't just say vertical angles. Vertical angle theorem. Okay. All right. So let's do a proof now. And I'm pushing the time here, so let's do a proof. All right. So here's the scenario here. I'm going to use this here. Here we go. So we've got this scenario. We've got a quadrilateral. Oh, didn't draw those the same length apparently. Okay. And I'm going to draw the diagonal of a quadrilateral forming two triangles. Okay. And let's say we're given this information here. We're given A, B, C, D. And we're given AB is congruent to CD. So AB is congruent to CD. And we're given AD is congruent to BC. AD is congruent to BC. Prove triangle ABD is congruent to triangle BCD. Now, when you write a triangle congruent statement, don't forget you've got to line up the corresponding parts. That means A is going to correspond with B, B is going to correspond with D, D is going to, or C, and D is going to correspond with D. A, B, D, C, you know what? B, C, ABD, ABD, I got it all wrong. Back up. ABD is going to correspond with CDB. CDB. There we go. And that's exactly what I'm talking about. A has to correspond with C. B has to correspond with D. D has to correspond with B. Okay. So let's do the proof. We have statements and reasons, which are rules that allow or justify what you did. Typically, we start with the given. So start with the given. AB is congruent to CD, and AD is congruent to BC. Okay. And statement 1, how do we know those are congruent? Because they were given as congruent. Okay, and then the last step, which I don't know the number of, triangle ABD is congruent to triangle CDB. And the rule I don't know yet, but let's fill in the steps. Okay, look for one of the two rules I mentioned before, either the bow tie principle, which is the vertical angle theorem, or the Siamese twin rule, which is the reflexive property, shared parts. Now, if you look at it, this has shared parts. This side is shared between both triangles, and anything is congruent to itself. So 2, we're going to say BD is going to be congruent to, segment BD is going to, you could say BD or DB. I'm going to flip it around because they're congruent that way, but flipping the order doesn't change the segment. And how do we know they're congruent? That BD is congruent to DB. Anything's congruent to itself, the reflexive property. Reflexive property, technically the reflexive property of congruence. Okay. And guess what we have now? We've got a side congruent to a side. We've got a side congruent to a side. We've got a side congruent to a side. That's 3 pairs of congruent sides. Therefore, we have what we came for, what we needed. We have side, side, side. So triangle ABD is congruent to triangle CDB, ABD, CDB. Good. Step 3, by the side, side, side triangle congruence postulate. Okay. QED, quod erat demonstrandum. I said it, therefore I proved it. Quad, I said it, like quote, erat, therefore, ergo, demonstrandum, demonstrated, showed, proved. Okay. All right, I've gone long enough.